Guys, today we're going to go through IXL Assignment YPQ, Probability of Compound Events. Let's first briefly talk about what a compound event is. So a compound event is when you have a combination of two probabilities. You can either have an AND compound event or an OR compound event. An AND compound event, like we see here in red on the left, is when you are having two events together. So if we, think about a bag of marbles and we are pulling out two marbles and I want to know what the chances are of picking one blue and one red, I'm going to multiply the two probabilities together to get my compound probability of the chances of picking both a blue and a red. The other version is an OR statement. So that is when you are picking one or the other. When that happens, you add your two probabilities together. So if we have a bag of marbles and I want to know what the chances are that I pick a blue or a red, we have our individual probabilities and those are added together to get our compound. All right, that was a super quick explanation. Let's hop on over to IXL so we can actually get some practice in. All right, here we are. Let's get started. So first question, what is the probability of both coins landing on heads? If we want to know the probability of both coins, that means it's going to be an AND statement because it's both coins together. So first, we need to find the probability of each individual one. So for my first coin here, the probability of it landing on heads, well, I have two total sides to my coin, and there is one side that is ahead. So I have a 1/2 chance that the first coin will land on heads. For our second coin, it happens to be the same. Now, I want to know the chance of it landing on heads. I have 1 out of 2 possible chances. To get the compound probability that both of them will land on heads, it's an AND statement. They are together. We are going to multiply. Remember, when you multiply fractions, you go straight across. So numerator times numerator, denominator times denominator. 1 times 1 is 1. 2 times 2 is 4. Can we simplify that fraction at all? No, we can't. So we should be good, but let's read our directions to make sure this is how we are to enter our answer. Write your answer as a fraction or a whole number. With fractions, use a slash. So we're good to go. So there's a 1/4 chance that both coins will land on heads. What is the probability of flipping tails and rolling a 1? All right, we have another AND statement. We want to know the combination of the two. So let's find each probability separately first. With our coin here, it wants the probability of flipping tails. Well, we have a 1 out of 2 possible chances that it will land on tails. For our die, we want to know the probability that it'll land on a 1. Well, on my 6-sided die, only one side has a 1 on it. And there are 6 possible sides, so 6 possible outcomes. Let's multiply these together to see what the chances are of getting both of them. 1 times 1 is 1. 2 times 6 is 12. Can we simplify that fraction? Nope. So there is a 1/12 chance. Let's actually bump it up a notch now, guys. What is the probability of flipping heads and rolling an odd number? Ooh, that's fun. First off, let's find the probability of flipping heads. That would be a 1/2 chance. How about the probability of rolling an odd number? Well, if we think about the die, our numbers go 1, 2, 3, 4, 5, and 6. My odd numbers are 1, 3, and 5. So there are 3 possible chances I could roll an odd number out of 6 outcomes. We want to know the total. It's an AND statement. Means we're multiplying. 3 times 1 is 3. 2 times 6 is 12. Can we simplify this fraction? Yes, we can. Whenever you can simplify, you need to do so. What would be a common factor? 3. We can reduce, we can divide by 3. So 3 divided by 3 is 1, 12 divided by 3 is 4. So there's a 1/4 chance of me flipping heads and rolling an odd number. Decent odds, considering. Let's try this one. What is the probability of spinning blue and rolling a 4? All right, if we look at our spinner here, we have 1, 2, 3, 4, 5. All right, my pointer is not working here. Let's erase this and try counting again. We have 1, 2, 3, 4, 5, 6, 7. So 7 of these sections are blue, and there are 8 total sections, 8 total outcomes. For rolling a 4, one side of the die is a 4, 6 possible outcomes, 6 total sides. I want to know the probability of doing both. It's an and statement. I'm going to multiply. 7 times 1 is 7. 8 times 6. 8 times 6 is 48. Can I simplify this at all? When it's one that's a little bit harder to tell, I kind of go through my divisibility rules. So if in order for it to be divisible by 2, they both need to be even numbers. Nope, doesn't work. In order for them to be divisible by 3, well, 7's not divisible by 3, doesn't work. If it's not divisible by 2, it's not divisible by 4. If it's not divisible by 2 and 3, 6 doesn't work. All right, how about 7? Well, if I think about my factors of 7, I go 42 and then 49. So nope. So it is not, there are no common factors other than 1. It's not able to be simplified or reduced. That means that is our final answer. Let's kick it up another notch. What is the probability of picking a blue marble and rolling a 5? So picking a blue marble, I see that I have 2 blue marbles, and there are a total of 2, 3, 4, 5, 6, 7, 8 marbles. Rolling a 5, I have a 1 out of 6 chance of doing that. I want my combination of both together. 2 times 1 is 2. 8 times 6 is 48. Can we reduce this? Yeah, they're both even numbers. I can divide by 2. So 1/24. That is the chance of getting a blue marble and rolling, a 5. All right, it is now your guys' turn to try it. So I think you can do it. I personally love probability. It's super fun. I hope you're enjoying it as well. If you have any questions, feel free to send an email or come to a help session. Bye.